Okay, we're back to continue configuring timer 1 on the ATmega 328P to do the PWM output on PB1 and PB2 pins. So we have two PWM outputs, and we've already configured our input capture register as 20,000, so that configures the period of our signal, 20,000 microseconds. And we have set the OCR1A H and BH to the high byte of 1500. Now we're going to finish setting the OCR1AL and OCR1BL to the low byte of 1500. So this is continuing where we left off. And so we're going to do STS to OCR1AL and STS OCR1BL. Oh, and before I forget, I noticed one mistake I think I made earlier. On our input capture register, it says ICR1H and ICR1L, and I named it just ICRH and ICRL. So we're going to need to fix that here. So that should be ICR1H and ICR1L on those two, so that we don't get an error on our name. So that configures the output compare registers or input capture register. Now we can configure the timer counter configuration registers. So we want to do a fast PWM with the input capture register being the top value, and we want to do a non-inverted PWM, which means we need a compare output mode bit set so that the pulse goes high at 0 and then goes low when it has a compare match with OCR1A or OCR1B. So let's look at the data sheet. So we have a data sheet. We're going to go to timer 16-bit timer counter 1. That's the 8-bit. And 16-bit timer counter 1. And then we want to go to the register descriptions under there. And so we want to look at the TCCR1A and B and configure those. So our compare output mode bits, remember we wanted it to set at 0 and go low when we have a compare match with OCR, when we have a compare match with OCR1A and OCR1B. So we're going to be using fast PWM mode. So we have a fast PWM mode table here. We want to set it at 0 and clear it when a compare match. So this one does a clear on compare match and sets at bottom, non-inverting mode. So that's what we want, non-inverting mode. So we have a 1 on COM1A, and we're doing both COM1A1, COM1B1. So we're doing both OC1A and OC1B. So we need to set both COM1As and COM1Bs. So I have a little spreadsheet that I made. I put it up on our shared Google Drive. So this spreadsheet, it's called MCU config 328 ODS. And what it is just a little utility. I can manually put in my bits here, and it basically writes the line of code I need to configure those bits. So we can go ahead and set these up as needed. So we wanted to have a non-inverting mode PWM. We need a 1-0 on both COM1As and COM1Bs. So let's go ahead and set those to a 1-0. And then here a 1, and here a 0. Then we'll have to come back and set our WGM. But let's go back to our data sheet here. And so that sets our compare output modes. Now we're going to have to set the WGM bits. So WGM 11 and 10 are in TCCR1A. WGM 1.3 and 1.2 are in TCCR1B. So if we scroll down a little bit, we see the table full of WGM bits here. And remember, we wanted a top value to be our input capture register. And then we want fast PWM. So if you see the column with the top values here, we have, this is PWM phase and frequency correct with the top value of input capture register. This is a clear timer on compare match with the top value of input capture register. But then down here, we have a fast PWM with the top value of input capture register. So this is the one that we want to use, the fast PWM with the input capture register being the top. So WGM 1.3 and 1.2 are 1s, WGM 1.1 and 1.0 is a 1.0. So they're all 1s except WGM 1.0. So let's go back and configure those. So this is a 1 here, and that's going to stay a 0 there. And this is a 1 on the TCCR1B, is a 1, and a 1 on there. So WGM 1.3, 1.2 are 1s, WGM 1.1 and 1.0 is a 1.0. Now our clock select bit, remember we were going to do the, we needed to count to 20,000, and our timer counts to 65,535. So we can divide the CPU clock by 1 and get up to 65,535. So if we look at the TCCR1B, in the clock select bits in TCCR1B, you see the table right here, and a divide by 1 is a 001. So the CPU clock divided by 1 is 001. So we have that set here as a 001. And our WGM bits are set. We don't need to set the input capture noise canceling or the edge select. So these 4 lines are all set to copy. And let's see if I can do this. So I selected all 4 lines. I'm going to copy them. I'm going to go back to our program here and paste them and see what we get. Sort of. Okay. So we have okay, we have we got the first 2 lines. Okay. So that's WGM 1.1 and 1.0. So we got TCCR1A, and we need to go back to copy these 2 lines. Copy those 2 lines, and okay. So we got those 2 lines. So we have the waveform generation mode bits, and then at the instant we set the clock select bits, the timer is going to start counting. What we probably should do, if we're going to use an interrupt, which we are planning to use an interrupt to configure or update the pulse width modulation, and that we were going to do when the timer has a compare match with the input capture register. At that point, it's going to have a timer overflow interrupt. So we already have OVF1 ADDR configured, but we need to enable that interrupt in the TIMSK1 register. So if we look over here in TIMSK1, you see the TOIE1 bit here. So we need to set that bit. So I want to do that before the timer starts. So I'm going to do it up here. So that has a NA address on the IO address, so we're going to have to use the store command, STS command, to output to it. So LLDI, and then we want to use our shift notation here, so shift to the left. And the position we want it to be in is TOIE1. So we put in TOIE1, right? And then STS to TIMSK1. 1 from temp. So that enables that interrupt. Now we're going to have to remember to write a little function. So at this point here, we could test it, and we should see the pin value toggling on the OC1A and OC1B values. So let's go ahead and if we're going to use the interrupt, we need to do a global interrupt enable. So SEI, and then we need a main function. So for now, we could also configure the sleep mode enable and put it into idle mode and let it sleep while it's waiting for the timer to count up. That could save some battery, and it'll wake it up every time it needs to update the pulse to the servo motor. We'll go ahead and do that later. Let's go ahead and set create a sample interrupt service routine just to have it someplace to go to. So we named it up here on our RJump instruction PWM update. So we can copy that name and put it down here with a colon after it. And for now, just to test our program, so this is a interrupt service routine. So at the end of it, we need to do a RETI command. I'm going to assemble this program and see if we have any errors. And I do. Apparently I have a typo here. This should be WGM. 1, 2. And assemble again. Okay, so that was the only error. Couldn't have had it quite perfect. So we can simulate this, and we could check our period on our frequency. Remember, it should be 50 milliseconds or 50 cycles per second, or 20,000 microseconds, and 1500 microseconds. And we can also verify that our OCR1A and B registers are getting updated at the timer overflow. You'll notice on the document for the OCR1 on the WGM table, mode 14 is the one that we use, WGM 141110. So it says here update at bottom for the OCR1X, which is A or B. So at bottom, so it updates the value when our counter resets to 0. So let's go ahead and start. We can simulate this. We're going to end up making another video to finish this. We're at like 13 minutes out of 15-minute limit right now. So I'm going to go ahead and do an auto step down to main. I don't have time to explain every step along the way. So we see our registers are configured. Our counter is counting. I want to set my breakpoint. For now, we'll set one at the PWM update. I'm going to toggle the breakpoint there. And we'll set one. We didn't enable the interrupts on the OC1A and B. So if we want to see that simulating, we'll have to enable the interrupts or time it until we get to 1500, which could take a while. So I'm going to run it right now, full speed ahead until the breakpoint. And okay, I'm going to be waiting a while because I set the breakpoint on the wrong line. It's supposed to be up here. Okay, we'll toggle that breakpoint off. Okay, let's try this again. Okay, I'm going to reset the stopwatch and run it again. Okay, so we have exactly 20,000 microseconds. And we're just about out of time here, so we're going to pause or stop for now, and we'll have to continue on another video. So see you on